Good evening, kids. I'm your Sridhar sir, physics faculty. Today we are going to discuss the 3rd April shift to evening JEE Mains 2025. The question paper is moderate, and it's better said like a moderate and the formula based. Number of easy questions are around 13, moderate questions are 9, and the tough questions are around 3. And the question paper is purely formula based, almost like all the topics they have covered it. Very good score needed. A very good scoring chapter also, like good paper. uh, the time around 55 minutes you can finish off the paper, really, and less calculations also, not like heavy calculation, so moderate and simple formula based with the least calculations. There's a overall the paper strategy. Then how to prepare to like those who are writing the 4th April or the 7th and 8th sessions, and the 6 shifts are there. You have to read all the theory once again, or how much all possible recollect all the concepts, then go for the formulas, recollection of formulas. J means is all about reading and recollecting formulas. The last moment, no need to do PYQ. How much all possible recollect all the ideas. Okay, fine. So we'll start the paper discussion. So let me give the explain all the questions in detail, and what is the method, how we should think, what is the formula involved, everything. Let me explain. So let me start it. Okay, this question based on the chapter wave optics. The idea of the interference is interference of light produced by the two coherent sources. The ratio of intensity of two coherent sources is 1:9. The ratio of the maximum to minimum intensities. I think we know the formula for this. I max, maximum intensity, is given by root I1 plus root I2 whole square. This will be how much? Root 1 plus root 9 whole square. This will be 16. I minimum will be root I1 minus root I2 whole square. My negative sign will be there. So this will be root 1, root 9 whole square. 1 minus 3 will be 2, 2 square will be 4. This is the I minimum. Is asking the ratio I max to I minimum. 16 by 4 by 4. Somehow you should know this formula. And you should know the basic idea of what you mean by interference, constructive interference, destructive interference. For constructive interference, the phase angle, there's a path difference. The path difference is equal to n lambda. Constructive interference, path difference equal to 2n minus 1 lambda by 2 destructive interference. All these formulas. And the resultant intensity depends on I1 plus I2 plus 2 root I1 I2 cos phi, where the phase difference between the waves depends upon the path difference. If the path difference n lambda or 2n minus 1 lambda by 2, this will be constructive interference, this will be destructive interference. Like this, all the formulas you must know. Then okay, along with this also formula. Like this, the basic background if you have, you can manage exam very easily. Yeah, fine. Reading everything, remembering. Sir, but I'm reading, I'll forget. Read again. There's only the strategy left over with the JEE Main, sir. We'll take the next question. We have the next question based on the topic, based on the chapter, alternating current. Here, the idea involved is AC signal with pure resistance only. This particular based on this topic. So let me read the question. An electric bulb rated as 100 watt 220 volt is connected to an AC source of RMS voltage 220 volt. The peak value of current through the bulb. He has given this wattage and the voltage rating. Then from this we can calculate the power dissipated equal to Vrms square into R. We'll calculate the resistance. So power dissipated is how much? 100. 220 whole square by R. The value of R will be by 100. This will become 440 ohm. Now the same, this particular resistance now, where it is connected? It is connected across the RMS AC voltage. So there's a AC source. What is the RMS value of this? 220 volt. The resistance of this is 440 ohm. It's asking the peak current through the bulb. What is the expression for IRMS? IRMS should be equal to VRMS by R. VRMS is how much? 220 volt. 220 by 440. So this will become equal to how much? 1 by 2 ampere. The peak value of current is being asked. Okay, here calculation mistake. 2. Okay, 0. So 22 into 22. I think some calculations I need here. Let me rewrite again. 22 into 22. It will be this will be 484 ohm. This 484 ohm, I'll connect it here. Then this will become 484. This will be VRMS value. RMS value is 220 volt. Now the peak value is needed. Peak value will be IRMS into root 2. Because IRMS equal to IM by root 2. IM will be IRMS into root 2. So 220 by 484 into root 2. Okay, 484. So okay, this will be calculations. We can simplify it. 220 is there. 484 is what? 22 into 22. 122 will get cancelled. 10 root 2 by 22. This will become 5 root 2 by 11 ampere. This you need not to expand 484. Keep as it is 22 into 22 and manage the calculations. And we'll move to the next question. Okay, kids, this question is belongs to the chapter kinetic theory of gases. And the idea involved is ideal gas equation. Let me read the question. Pressure of ideal gas contained in closed vessel is increased by 0.4%. When heated by 1 degree Celsius, its initial temperature must be. The concept based on PV equal to nRT. Closed vessel. What do you mean by closed vessel? Volume remains constant. This will be constant. Then delta P by V equal to nR delta T. Dividing these two, delta P by P is equal to delta T by T. Increase it by what percent? 0.4%. The pressure is increased. So 0.4 by 100. When temperature is increased by 1 degree or 1 degrees or 1 Kelvin, what is the initial temperature? This is the initial temperature. So T will be 1000 by 4, 250 Kelvin. Somehow this meaning of closed vessel means volume constant. This is, you have to say, I think you should be very good in English, no? That's why those who are preparing for JEE Mains, those who are writing the English exam, better you get habituated for English teaching. It'll be easy for you in exam. If you learn in Hindi, okay, fine, good. But how you deal with the language? If you are Hindi medium, okay, fine, good. But if you are writing the exam in English, preferable English teaching, so that you'll get habituated with the words. This will be a big loss for students who get adapted to the Hindi teaching. Okay, fine. We'll move to the next question. Okay, so this question based on the work energy power. And the idea involved is conservation of mechanical energy. Let me read the question. Two cylindrical vessels of equal cross-section area. They given this cross-section area 2 meters square, contain water up to height 10 meter and 6 meter respectively. The vessels are connected at the bottom by then the work done by the force of gravity. Then here mass of the liquid will be m1, m2. The initial energy will be m1 g h by 2. H by 2 will be 10 by 2. There's the initial, because where the center of mass of this left 2 will be at a height h by 2 plus m2g, height, the level of liquid is 6 meters, center of mass will be exactly at the 3 meter. So this will be 6 by 2. What is m1? M1 will be rho, area of cross section, A, volume will be 10. This will be the A into 10 will become volume. G 10 by 2. This will be m2 will be rho A 6. G 6 by 2. So the initial energy will be rho A G you take outside. 10 square 100 by 2 will be 50. 36 by 12 will be 18. So this will become 68 rho Ag. This is the initial potential energy. Finally, the liquid will attain the level H. The volume should be conserved, no? The mass should be conserved. What was the earlier mass? The same mass it should be. So what was the initial volume? Conservation of volume if you apply. Rho, okay, only conservation of volume. Based on that, A into 10 plus A into 6 should be equal to AH plus AH. So this will be 16 equal to 2H, H equal to 8 meter. The level of liquid in both the vessels will be up to 8. Then final potential energy of the system will be, here the mass will be rho A G H by 2. Okay, it is like this. Rho A H is the mass of the liquid in the left vessel. G H by 2. Similarly, here the mass of liquid here will be rho A H G H by 2. This will become rho A G H square. Rho A G as it is. H square will be 8 square. Will be 64 rho A G. Then the work done by gravity, the decrease in gravitational potential energy. Work done by gravity should be equal to Ui minus Uf. The difference of this will be 4 rho Ag. Substitute the value. 4 and density of water 1000, area of cross section 2 into 10 will be 80,000 joule. Now there's a basic concept. So why h by 2? Center of mass will be here, exactly at half of the level. Okay, then we'll move to the next question. This question based on the chapter semiconductor physics, the idea involved is logic gates. The truth table corresponding to the circuit given below is. Here the truth table will be, this is the input A, so this will also be A. The input B and this OR gate, the output of the first OR gate will be A plus B. Now this will become A plus B input and there is an AND gate. The output C will be equal to A dot A plus B. Okay, this will be expansion A dot A plus A dot B. A dot A will be A only, yeah? Because A equals 0, output will be 0, A equal to 1, this will be A. Then this will be AB. Take A outside, 1 plus B. Whether B is 0 or 1, the output will be 1 only here. 1 plus B will be 1 only. Okay, this will be your option. This is about the logic gates. Those who are preparing for the 4th, 7th and 8th shift, the logic gates, they are asking numericals more. Earlier they used to ask more about the theoretical one. Now they are asking more numericals. Little bit be alert. You have to work out numerical based questions. And this question belongs to the chapter surface tension, and the idea involved is excess pressure in soap bubble. This formula is what you should know. Okay, let me begin. There's a bubble A, there's a bubble B. Excess pressure inside bubble A is half that of the bubble. Excess pressure is asking. So delta P A should be equal to 4T by RA. Then excess pressure in the bubble B will be 4T by RB. What is the condition given? Excess pressure in bubble A is half of this one. So this will become 4T by RA 1 by 2. Two times of RB. Find the ratio of volume of the bubble. VA by VB. 4 by RA cube equal to 4 by RB cube. So RA by RB will be 2 cube, which is equal to 8. So 8 is to 1. Then this formulas should be there with you. Excess pressure will be 40 by R. For the drop, it will be 2T by R. Okay, fine. A monochromatic light of frequency traveling through air is incident on a medium of refractance to wavelength of the refracted light will be. Frequency is given, refractance 2 is asking to get the wavelength. So first of all, we know the refractive index. We can calculate the speed of the wave. V equal to C by mu. 3 into 10 to the power of 8. Refractive index is 2. Will be 1.5 into 10 to the power of 8. After getting this, F equal to V by lambda. Frequency 5 into 10 to the power of 14. Speed is 1.5 into 10 to the power of 8. This will be the wavelength. Wavelength here it will be we'll substitute here. This will be 3 by 2. 1.5 I'll write 3 by 2. 3 by 2 10 to the power of 8 divided by 5 into 10 to the power of 14. 3 by 10 or 0.3 into 10 to the power of minus 6. 14 minus 8 minus 14 will be 10 to the power of minus 6. This can be adjusted as 3 into 10 to the power of minus 7 or 300 into 10 to the power of minus 9 meter or 300 nanometer. Just basic definition. Speed of light in any medium equal to speed of light in free space to the refractive index. I think this you must know. And for any wave, F equal to V by lambda. Frequency equal to speed of the wave in that medium by wavelength of the light in that medium. This chapter based on experimental physics. Errors. Physical quantity C is given as C equal to P by Q R cube to the root S. Find the percentage change in C. If percentage change in P, Q, R and S are this much. 1, 1, 3 and 2. So what is the formula? This will be dC. Relative error in C is equal to relative error in P, relative error in Q, relative error in R, relative error in S. Okay, all this one. So relative error in P. Relative error in P is how much here? 1. Relative error in Q, 1. Relative error in R, 3. Relative error in S, 2. 1 plus or minus 1 plus or minus 1 plus or minus 9 plus or minus 1. The relative error will be 12. Everyone must having idea of this relative errors. The one which are power into power times the error will get multiplied here. Here it's like a R cube 3 into dr by r. Here root s 1 by 2 ds by s. And always the errors should be added. You should not subtract this one. So like this is denominator minus 3. No, always you have to express maximum possible error. Okay, kids, we have the question here based on units and dimensions. Dimensional analysis. The physical quantity is given. We have to match with the dimensions. Let me start with the quotient of viscosity first. The quotient of viscosity. What is the basic formula? Quotient of viscosity. F equal to eta A dV by dx. Force will have unit m1, L1, T minus 2. L square. This will be velocity L T minus 1. This is the L. So quotient of viscosity will be, this L will get cancelled out. This L will cancel out. And here L minus 1, T minus 3. Quotient of viscosity M1, L minus 1, okay, T minus 1. Okay, this will be our condition. Okay, the B is matching with 4. I think these two are ruled out. You need to give stress. You can, so these two are ruled out. Now between these two is what we should check it. We'll take the easy one, thermal conductivity, or you can take the Planck's constant. We'll take the next Planck's constant. Planck's constant means E equal to hf. Energy and dimensions of energy m1, m1 mgh, no, L square T minus 2, or force will be, energy will be force into displacement, so m1 L square T minus 2. Dimensions of h, dimensions of frequency will be T minus 1. So this will become, dimensions of h will be is equal to m1 L square T minus 1. M1 L square T minus 1. So this will be the dimensions of the Planck's constant. So C will be 1. C is 1. It's available here. And B is 4. You need not to check the other things, sir. This is what you should do in exam. You should save the time. Got the idea? This one. So this will be ruled out. No need to check Boltzmann constant, thermal conductivity. Okay, I'll explain it. Thermal conductivity will be like a dq by dt is equal to Ka delta T by L. This is the like a energy. This will be similar to the energy. The energy will be m1. This is the power. Power. This will be m1 L square T minus 3. Thermal conductivity of K, L square, Kelvin, K1, and this is L. So thermal conductivity of, dimensions of thermal conductivity will be M1, L1, T minus 3, K minus 1. So this will be, D will be 2. Rest all Boltzmann constant. Boltzmann constant will be K, no? Average translational conductivity 3 by 2 kT. Boltzmann constant, how to define that one? It will be average translational conductivity will be 3 by 2 kT. Kinetic energy, what is the kinetic energy will be? M1 L square T minus 2. Dimensions of K, this will be K. This will be M1 L square T minus 2 K minus 1. Okay then, so these are the ways in which you should work out. Just practice is needed. Okay, this question belongs to the chapter friction, and the idea involved is friction on moving block and work done by variable force. Some rough surfaces, some sort of frictional force will be there, and variable friction force will be acting. A block of mass 1 kg moving along x-axis with speed 10 meter per second enters a region ranging from 0.1 meter, rough region ranging from 0.1 meter to 1.9 meter. The retarding force acting on the block is F equal to minus kx, with k equal to, find the final speed of the block as it crosses the rough region. This is the rough region. This region is rough. And now the force is proportional to minus 10x. Yes, the body will undergo retardation. Then initial kinetic energy 10 meter per second. We have to calculate this final speed. So initial kinetic energy F dx mv square by 2. This will be 0.1 to 1.9. Mass of the block 1 by 2. Initial speed 10 square. Force will be equal to 1 by 2 into v square. So this will be 50 minus, okay, this will be plus. Why negative? Why negative sign? It will act opposite to displacement. So therefore this negative sign is there. So minus of 10 x square by 2, 0.1, 1.9 v square by 2. 50 minus 5, 1.9 whole square minus 0.1 whole square v square by 2. Solving this, final speed of the block is asking. So little bit calculation, there's no other way in exam, you should be very good. 1.9 whole square, 3.61, 50 minus, this will be minus 0.1 v square by 2. 50 minus 3.61 minus 0. Will be 3.6. 50 minus 3.6 into 5 will be 18 v square by 2, or v square equal to 64, v equal to 8 meter per second. Calculations you should be very good. This part you look at. There's a work done by variable force, and that force is retarding force. That's why the speed will decrease. It entered with speed 10 meter per second, here 8 meter per second. Work done by variable force concept. Look, it's this question based on the, here it is waves and sound chapter. Idea of the organ pipes and bits, both are combined. In the resonance experiment, two air columns closed at one edge of 100 centimeter and 120 centimeters. Two organ pipes, length of one is 100 centimeters, the other one is 120 centimeter. Gives 15 beats per second. When they vibrate together, will give 15 beats per second. And each one is sounding in the respective fundamental. Half loop will be there in each one. The velocity of sound in the air column. You have to calculate the speed of sound in both these. So the 15 bits first F1 will calculate. F1 will be speed of sound by 4L1. F2 will be speed of sound by 4L2. The one which is smaller length will have the more frequency. So F1 minus F2 is equal to how much? 15. This will be V by 4L1, V by 4L2 equal to 15. Further solving, speed of sound we have to calculate. Here 4 will go on that side. L1 will be 100 meter, you convert into meter. This will be 1 meter. 4 into 1. This will be L2 will be 120 centimeter, 1.2 meter equal to 15. V. 4 also will take this one, 1.2 minus 1, 1.2 into 60. So 0.2, or this will be 2V by 12 into 60. 6 will be 360 meter per second. Some of the resonant frequencies of closed end or fundamental frequency of the closed end organ pipe, F will be V by 4L. Next, first overtone 3V by 4L. Next will be 5V by 4L. If you know this formula, okay, you can manage this question. Okay. A magnetic, okay, the question belongs to chapter moving charges and magnetism. Then magnetic torque on current loop. A magnetic dipole experiences a torque of, when placed in a uniform magnet such a way the dipole moment makes an angle 60 degree with the magnet. The potential of the dipole is asking. Torque equal to mb sine theta. Then torque is how much? 80 root 3. The dipole moment with placed in uniform magnetic field. The dipole moment makes an angle 60 degree. mb sine 60 degree. So 80 root 3 mb root 3 by 2. mb equal to 160. Okay, this is the value of dipole moment into magnetic field. What is the potential? Potential formula will be minus m bar dot b bar, which is equal to mb cos 60 degree. What is the value of mb? 160 cos 60 1 by 2 will be 80 joule. Formulas, you must know this formula. You must know this formula. Torque due to dipole moment kept in a magnetic field and its interaction potential G with the field. Okay, kids, done? This question is based on the chapter viscosity. And the idea involved is Stokes law in terminal velocity. This is a formula. So let me read the question. A spherical ball of radius 1.8 millimeter and density 7825 kg per meter dropped into viscous fluid having density. If it achieves terminal velocity of this much, find the coefficient of viscosity of the liquid. So what is the directly formula for terminal velocity? You should remember this formula, gr square by 9 eta. This will be density of the solid minus density of the liquid. 2 G value will be 10, diameter 1.8 into 10 to the power of minus 3 whole square by 9, eta value. Then the quotient of viscosity, this only we have to find out, will be density of the solid dropped into density 7825, density of the liquid 925. Okay, then terminal velocity will be 245. I think you should be a weak calculation. Huh? You should be careful enough. Huh? We have to calculate the eta. It will come this much. 2 into 10 to the power of minus 4 pascals second. You should manage with these calculations. Okay, fine. I don't have patience to calculate this. Huh? I'll move to the next question. This question belongs to the chapter current density. And we have the grouping of cells. Grouping of cells in series parallel. And the two situations given in figure 1 and 2. Current to R is I1. Here is current is I1. Here I2. If E1 equal to 2 volt, E2 equal to 1 volt, R1 1 ohm, R2 is 1 ohm. Okay, there's a ohm, huh? The symbol. And R equal to 6 ohm. Okay, fine. So we have this one. Is asking to get this current. Here they are in series. So what is I1? I1 will be equal to E1 plus E2 by R1 plus R2. E1 will be 2 plus 1, 1 plus 2. 1 ampere. What about current here? Grouping of cells. Huh? I replace these two cells with an equivalent cell. Okay, fine. This I2. Okay, now grouping of cells. So what is the value of E? E will be E1 by R1, E2 by R2, all divided by 1 by R1 plus 1 by R2. The value will be E1 will be 2 by 1, 1 by 2 by 1 by 1 plus 1 by 2. Five by 3. This will be 5 by 2. This will be 3 by 2. We'll get EMF F. This is 5 by 3 volt. The equivalent resistance R is given by 1 by R1. Hope you recollect all the formulas. 1 by 1 plus 1 by 2. 2 by 3 ohm. Then the current I2 will be E by, here E1, one R is missing. What is the value of R? 6 ohm. I didn't see it. This will be 6. This will be 3 by 9, 1 by 3 ampere. No. What is the expression for? Here E will be E by small r plus capital R. Value of E will be 5 by 3. Small r will be 2 by 3. Capital R is 6. Current I2 will be 5 by 16, 20. This is 18, 18, 20. 5 by 20 will be 1 by 4 ampere. Ratio of this is asking. I1 by I2. I1 will be 1 by 3. This will be 1 by 4. Will be 4 by 3. Grouping of cells, this formula. This formula is very important. And next, this formula. Series, okay, you know this one. It will be net EMF by net resistance. For when the grouping of cells in parallel, these are the equivalent, the internal resistance, equivalent EMF. Okay, this question belongs to the chapter collisions, conservation of linear momentum. The idea involved, a block of mass 10 kg is moving with speed 3 meter per second here, with a spring connected to another block of 5 kg, initially at rest, and the spring is relaxed. There is a condition. Find the compression spring when both move with the same speed. So when they are moving with a common speed, what is the basic condition is? They will have the common velocity, means at maximum compression, they will have common velocity. Then the compression in the spring will be Kxm. Both will be moving with a common velocity. Okay, fine. Both will be moving with a common velocity. Then applying conservation of momentum. Net force is 0. Applying conservation of momentum, 3 into 10 is equal to 10, or 10 into 3. Initial momentum 10 into 3. Final momentum 10 into V plus 5 into V. V will be 30 by 15, will be 2 meter per second. Okay, this will be the final velocity of the common velocity of the block. At maximum compression, both will have common velocity. This is a concept. At maximum compression, both the blocks will have this idea. You have to remember, useful for advance also. Then we'll apply conservation of mechanics. This is a conservation of linear momentum. Conservation of mechanical. Initial kinetic energy. This is a test. Spring is relaxed, no elastic potential energy, no kinetic energy. Only this having kinetic energy. So initial kinetic energy plus final kinetic energy plus elastic potential energy stored in the spring. What is the initial kinetic energy? Initial kinetic energy will be mass of the block 10, 3 square by 2. Final kinetic energy 10 V square by 2. plus 5v square by 2 plus k xm square by 2. This will be 9945. This will be 15 by 15 v square by 2. V value is 2 square. K value 3000 xm square by 2. Okay, finding, we'll get the compression of 0.1 centimeter. Will be in 0.01 meter. Convert into centimeter, we'll get this much of answer. Yeah. Conservation of mechanical energy, initial kinetic energy, final kinetic energy plus elastic potential. Conservation of net force is 0. Okay, done. Okay, this question belongs to the chapter moving charges and magnetism. And the concept involved is a charge particle moves in a magnetic field. It experiences a magnetic force F equal to QVB and is going to move in a circular path of radius R equal to mv by QB. This idea. Now the oxygen, hydrogen. So what is the expression for radius of the charge particle mv by QB? Now radius of the oxygen molecule is equal to mass of oxygen with same speed by charge of oxygen O2 minus the magnetic field will be same. What is the mass? Mass of oxygen will be 16 times mass of hydrogen, same speed. Charge will be 2 times charge of electron. Okay, this will become 8 mv by b. That for the hydrogen will check it. For the hydrogen will be mass of hydrogen, same speed projected, charge of hydrogen b. Mass of hydrogen will be m. Charge of one is like a H plus, no? So charge will be E B. So definitely this is 8, no? So what we are getting, RO greater than RH. Radius of the oxygen molecule, oxygen ion will be that of the hydrogen ion. Are projected, but the radius of the curvature of will be less than hydrogen, but we are getting more, so this is wrong statement. Then similarly, if electron and the proton are projected in magnetic field perpendicular field with the same speed, the radius of curvature of electron, mass of electron, speed, charge of electron b. Proton projected, mass of proton v, charge of b. Mass of proton will be greater than mass of electron, Rp greater than Re. The radius of curvature of E will be, electron will be more than the proton. No, in fact it will be less. So this is also wrong statement. Both statement 1 and statement 2 are incorrect. Just the formula, radius of the charge particle in magnetic field, mv by qb. Okay, this question belongs to the capacitors. And the idea involved is charge sharing. Okay, no, we'll begin like this. So there's a capacitor C1, 100 pico is connected to 60 volt cell and then disconnected. So how much of potential difference across capacitor C1 will be 60 volt. Is now connected to an uncharged capacitor. This is uncharged. No charge, initial no charge. The switch is closed. Then the final potential difference will be 20 volt across it. Then charge should be conserved. The charge of these two plates should be conserved. The charge of these two plates should be conserved. Either you can choose this plate or this plate. So what is the charge Q naught? 0. 0. Final charge Q1 plus Q2. Q naught will be C1. C1 will be 100. Pico I'll introduce later on. The calculations you can minimize here. So this will be Q naught will be C1 into 60. equal to Q1 will be C1 into 20. This will be C2 into 20. Charge equal to capacitance into potential. So this will become 6C1, 2C1 plus 2C2. 3C1, okay, this will be 2C1 equal to C2. This 6C1 minus 2 is 4C1, 4C1 equal to 4C2 or 2C1 equals C2. What is the capacitance? This will be 100 picofarad. So C2 will be how much? 200 picofarad. Charge sharing important. Capacitors. Okay, this chapter belongs to waves and so. The idea involved is resonance air column experiment. In a resonance tube experiment at one end, resonance is obtained at two consecutive lengths, L1 100 cm, L2 140. If the frequency of sound is 400 Hz. This is the F. Find the speed of the sound. Actually, this experiment is to find out the speed of the sound. At the first resonance occurs, we'll get the half loop. This will be the antinode. This will be the node. There's a water. The level of water I can control it. This upper surface of the water will become closed and this open end. Then next we'll get like this. One end of flow. Okay, then now what are the resonating length? Will be L1, this L2. In terms of wavelength, lambda by 4, 3 lambda by 4. So what is L1 is equal to? L1 equal to lambda by 4. L2 equal to 3 lambda by 4. Then L2 minus L1 equal to 3 lambda by 4, lambda by 4, lambda by 2. What is lambda? V by F. So speed of sound is 2F, L2 minus L1. 2 into the frequency 400, L2 will be 140, this 100. So always we'll get the speed of sound 320 meter per second. All this I explained. Exam directly you should know the formula. The speed of sound in the resonance air column experiment is 2F into successive resonating length L3 minus L2, L2 minus L1 or L4 minus L3. Okay, you have to directly substitute here and so on. You need not to think this much in exam. Got the idea? You should be ready with the formula for the exam. You should know the concept. You should be ready with the formula. Okay, the moment question comes, okay, this concept, okay, there's a formula, substitute, solve. There's a methodology for JEE Main, sir. Okay, kids, we have the question based on the ray optics and refraction at spherical surface. Chapter name ray optics, refraction spherical surface. Okay, the question, the two media of refractoriness mu equal to 1 and mu dash will write it. Some other symbol will give it. Mu dash equal to 3 by 2 are separated by a spherical surface of radius 50 centimeter. Image of object O is formed at distance 200 centimeter. This is the image. Find the object distance x. What is the formula for this? Refraction at spherical surface formula. Where the refracted ray will come like this. So the incident ray will come like this. Will undergo refraction and this will be the incident ray. Okay, there's a normal something. Then where the refracted is present in mu dash medium, so mu dash into object distance we know plus 200 minus the incident is present in a medium of refractiveness mu, object distance we don't know, minus x, because you have to measure the distance as measured in the direction of incident ray positive, so you're measuring x opposite incident ray, so negative. Mu dash minus mu, this will be plus r plus 50. Mu dash will be 3 by 2. So this will become 200. This will be plus x. 3 by 2 minus 1 will be 1 by 2. So this will, everything will be 100. So 3 by 400 plus 1 by x equal to 100. 1 by x equal to 100 minus 3 by 400. One by x equal to, or x equal to 400 centimeter. Okay. If an electron in hydrogen atom jumps from fourth excited state to nth energy state, 2.86 electron volt photon is emitted, the value of n. The question belongs to the chapter items. Wavelength of photon in hydrogen spectrum. The de-excitation process. That is the formula when fourth excited state. Just a small basic, like this is the energy level diagram. E5, E4, E3, E2, E1. Fourth excited state to some state we don't know that we have to calculate. So it is making transition from here. This will be fourth excited state. N equal to 5 will be fourth excited state. This is called like a ground state. Okay, no. So what is this will be 2.86 equal to 13.6 electron volt, 2.6 electron, 2.86 electron volt equal to 13.6 electron volt. N square minus pi square. 1 by nf minus 1 by ni square. So this will become 1 by 25. The value of n has to be calculated. So this will become 2.86 by 13.6 or 28.6 by 136 equal to 1 by n square by 25. Solving for n equal to this will be 28.6 by 136. 136. I'm using calculator. 0.21. Then this will be 1 by n square equal to 1 by 25 plus 0.21. Approximately we'll get, it will be 2. It should be good in mathematics. There's a formula for hydrogen spectrum, hope everyone knows, like E equal to the difference energy level. We'll move to the question. Okay, this question belongs to the thermodynamics based on the work done in PV graph. Find out the magnitude of work done in the process ABCD. What is the process? The process is here AB, BC and CD. We have to calculate the work done in the process. So then how much it is work done equal to area under PV graph. This will be change in pressure 3 minus 2 atmosphere, change in volume 2000 minus 1000 liter. So this will be 1000 atmospheric liter. 1 atmosphere liter will be 101. So 1000 into 101.3. We have to express in kilojoule. So 101.3 kilojoule. area, oh sorry, area we have to calculate, no, area will be 3 minus 2. Work done will be only 3, huh? This everything will become area. I forgot, huh? Just, okay, fine. Huh? No work done in the path CD and AB, only work done in the path BC. Huh? Now, let me explain clearly. Work done in the path AB and CD 0. So net work done is what? Work done in the path AB, CD plus BC. Here this is 0, this is 0. Only work in the path BC is the work done. Okay, fine. Now this will become 300. And then this will become 304 kilojoule. This is a simple thermodynamics. Area under the PV graph will give the work done. Okay, kids, we had a discussion on the 3rd April, shift 2, the evening shift, JEE Mains 2025. The paper was moderator. Once again, those who are preparing for the 4th April, 7th April, 8th April, the method is read the concepts. Just plain reading, keep on read it. We have so many videos everywhere in the YouTube or here app, webs. Utilize them. Utilize them, that one. Just watch it. Nothing wrong, not just watching, that watching. Any channel where some good explanation is there, watch them. Recollect all the concepts. Just keep on listen. Just keep on listen. Nothing wrong. Then next, again, formulas. Formulas, there's no other choice, you have to memorize. Then solving PYQ. For whom? Those who are dropper, okay, fine. Those who are writing 4th, 7th, 8th, don't solve PYQ because this is not the time. Focus more on these things. The dropper, those who are dropper, go for it. We have a time, no, 8 months, solve PYQ. This is very important. The watching is nothing but the learning here. You have to just make observation, okay, how that equation is there, how it is derived, what is the concept involved, like that you have to do it. How you watch movie, like that you watch. Physics movies, chemistry movies, maths movies, nothing wrong, nothing, see, like the way of learning has changed. It's not that something you should sit, take book. You can learn through the app, website or the YouTube channels. But you must put effort. See, there's no magic formula. Nobody within 1 hour or 2 months or 1 day or select this one, nothing is there. You have to just plain reading is needed. What are the total syllabus? You have to watch it. So one shots are there. Watch one shot. Some idea, some help will be there. Then memorize formulas. Memorize formulas, you have to remember. There is no other choice. How to memorize? Daily reading. Fine. So all the best for the kids who are appearing for the 4th, 7th and the April shift. Okay, thank you everyone for great support. So we will meet tomorrow for the 4th April, the shift 1 and the shift 2 papers are uploaded. Till then, take care all of you, and the 4th April students, all the best. I'll end up the class. Okay, bye.